using function notation to solve for x. When we're solving for x, that means we know the value of the output. We know f of x, which means y. And then we use our function rule and inverse operations to solve for the input, to solve for x. This is just like when you have a linear equation and you know y, you use inverse operations to solve for x. It's exactly the same process. Here's an example. Let m of x equal 2x minus 3. If m of x equals 15, find x. The work is shown here. What we do when we're given the value of the output is replace the f of x, in this case the m of x, with the value of that output. So we're plugging 15 in for m of x. We're plugging 15 in for m of x in that function rule. Now we have an equation to solve. 15 equals 2x minus 3. Just like for any equation, we're going to use inverse operations to solve. So first we add 3 to both sides of the equation. 15 plus 3 is 18, equals 2x minus 3 plus 3 equals 2x. Last inverse operation is to divide both sides by 2, and that gives me my answer to my question. The answer to my question is that x equals 9. The input of my function, given an output of 15, is 9. Again, I could write this entire function notation statement that summarizes my entire finding. Given the function m, for an input of 9, the output is 15. But what I was asked to find was the input, to find x, so stopping right here is totally fine. X equals 9. Next example. Let w of x equal 3x minus 6. If w of x equals 24, find x. We are given the value of the output. We are given w of x. We're therefore going to replace w of x with the value of that output with 24, and then we're going to use inverse operations to solve. So 24 in for w of x equals 3x minus 6. And if you prefer, it's totally fine if you write 3x minus 6 equals 24. That's a-okay. Let's solve by adding 6 to both sides. That gives me 24 plus 6 is 30, equals 3x. And then dividing both sides by 3, I have my solution. My solution is 10 equals x, x equals 10. What I have discovered, or what I have found, is that given an output of 24, for the function w of x, the input is 10. My entire function notation statement would be w of 10 equals 24. Given an input of 10, my output is 24. Last example. Let g of n equal 2n minus 5. Find n for g of n equal to negative 35. We're going to replace g of n with negative 35 and solve. Negative 35 equals 2n minus 5. We are super great at solving equations at this point. Adding 5 to both sides, negative 30 equals 2n. The last inverse operation is to divide by 2. I have negative 15 equals n equals negative 15. For the function g of n, an input of negative 15 gives me an output of negative 35. The function notation statement would be g of negative 15 equals negative 35.